Hi everybody. Today we'll spend an hour reviewing these new applications that we've added to our basic set of software that it comes with the purchase of our T1E1 hardware. So I'll get started, and Shashi will help me also explain some of these features. And I think you all are probably familiar that we all started, GL Communications started with T1E1 hardware first, and then a few years, or 3-4 years after that, we started into the packet domain and into the wireless domain. So we've expanded our test instrumentation, but initially we started with T1E1 hardware. So very close to my heart, since I was involved early on with the design of these things. But we've, as you can see, we've expanded the platforms. So many of you may be familiar with these, or you may even have experience playing with these. This is our, if you can see my cursor, this is our T-Pro, very versatile platform that has 2 ports. Almost all of our platforms actually have a minimum of 2 ports. The Octal card has 8 ports. The T-Scan 16 has 16 receive ports. This is the T1E1 Express card for PCI Express bus. So you all know that we've been tracking the PC architecture from the very beginning. We started off with what? The XT, remember that? The PC? We actually built cards for an XT interface, XT bus. And then there came the AT bus and 486 bus and all those different buses. So we've kept track of all of that. The latest and greatest bus, of course, is the PCI Express bus. And PCs also have the USB Universal Serial Bus, along with a variety of other interfaces, but these are certainly the 2 most important ones. So we have portable equipment that interfaces to the USB bus, and cards, low capacity cards as well as high capacity cards that interface with the Express bus. And this, with these set of platforms, we can practically address any capacity requirements that may arise. Okay, so these are the basic platforms, and when you purchase one of these, you get a set of basic software for T1 or E1, whichever you are interested in. And that basic software is, here's a big list of what that basic software is from the monitoring aspect and also from the intrusive aspect. So monitoring is non-intrusive, and of course intrusive means that we're actually disturbing the line. So the applications, to get to the point very quickly, the applications that have been added to the existing monitoring applications that you see on the left-hand side are these applications. One of them is called the Real-Time Multichannel Audio Bridge. I'll explain what that is in just a second. Jitter Measurement. You all know T1 lines and E1 lines, and in fact any transmission line is subject to something called jitter, meaning the rate at which, or the clock at which the signal is being transmitted can vary instantaneously from one frequency to another or one phase to another. So this is an impairment actually, and it should be minimized in the system. Otherwise you will get errors in just decoding the actual bits. So this jitter measurement is a very important measurement, and the ability to generate jitter and also measure jitter is very important. So we've included that capability into the basic software. Now this is only available for the T-Pro. Go back to this. It's available for this T-Pro platform, and it's available for the Express card, the measurement, and I think that those are the two platforms that it's available for. That's Jitter. Pulse Mask display. Again, for those same two platforms, we have the ability to actually visually see the actual pulse shape, and I'll talk about that a little bit more later. As you know, both T1 and E1 are electrical signals. They can be multiplexed into fiber and coax and so on, but inherently coming out of a piece of T1 equipment is an electrical signal. That electrical signal means that it's a pulse. So a 1 could be a positive pulse or a negative pulse, and it has to be a certain duration and a certain format. So it's important that as the pulse propagates on the line, that it experiences attenuation and distortion and so on. And so you have to make sure that that impairment is controlled and the pulse is received at the receiver correctly, or at least with some limited degradation, so that it can be recovered. So to make sure that two pieces of equipment are communicating electrically with the proper pulse shape and duration and so on, and with the least amount of degradation, this pulse mask display will measure at the receiver what that pulse actually looks like. So the way we do that, I'll explain that in a few minutes. It's kind of interesting. We take the actual electrical signal and digitize it at a very high rate and actually present that display. Another application that we've added is the signaling bit transitions. This was originally an optional application, and as you know, in the old technology, which is still out there, signaling bits is how we convey on-hook, off-hook, and connections in the TDM domain. So both in E1 and T1, we use something called A, B, C, D signaling bits, right? For on-hook, off-hook, and all sorts of other what are called channel-associated signaling. So to be able to see that on all 30 time slots and be able to record those signaling bits as they are occurring, this application will allow you to do that. DTMF, MF, transmit, capture. I'm going to have Shashi explain that. Shashi, can you?
Yes, Vijay. DTMF, MF transmit, then you can transmit DTMF digits or MFCR2 digits or capture them. I mean, I can explain that as we go to the slide.
Okay.
Yeah.
So real-time strip chart is another feature that we had as optional that's now been included. We'll talk about that as well. Okay, so those are the monitoring applications that we've added. Jitter measurement, pulse mask measurement, the signaling bit transmissions, and the DTMF capability being the most important. So those are all now basic, part of the basic. If you add up all of these new features that we've added, it would have normally, our normal cost for all of those was $8,655, but now they've all been included with the basic software. And so under Intrusive Tests, we have similar applications, Jitter Generation, so that we can actually impart jitter and measure whether or not the receiving unit can tolerate that jitter. So there's a method for measuring the sensitivity of a piece of equipment for receiving jitter, and there's of course a specification for compliance there as well. So this will allow us to both generate and measure jitter and test the compliance of a T1 or an E1 device for jitter. It's very important because obviously the first thing that has to happen before you turn up equipment is they have to be able to communicate, and they have to be electrically connected reliably. So jitter is one of those things. The mask, the pulse mask is another thing, the framing format, and so on. We added another application called T1 A-Law and E1 Mu-Law. So originally, this was added for actually a few special customers that are out there that actually transmit A-law on T1 lines, which is unusual, and they transmit mu-law on E1, which is also unusual. As you know, it's the reverse, right? T1 uses mu-law, E1 uses A-law. Those are codecs, 8,000 samples per second, 8 bits per sample.
Default coding for T1 is mu-law and E1 is A-law. This option allows A-law on T1 and mu-law on E1. And there are a lot of supported applications like transmit tone, record and playback, DTMF digits, spectral display, oscilloscope, all those applications are supported. So basically, this option allows A-law on T1 and mu-law on E1.
Right. Now, normally, this will not be applicable for most applications because, as you said, the standard is for T1 to have mu-law and E1 to have A-law. But since it's an application that's there, and it does come in handy once in a while in certain countries and in certain situations, especially sometimes, for example, in international circuits, when you're going from America to Europe or from Japan to Europe. Japan and the United States are the only countries that use mu-law. As soon as you leave those countries, you enter A-law, the A-law world, which is E1. And of course, when you digitally transmit between such countries, you have to abide by the receiving country, and you have to convert from A-law or from mu-law to A-law or whatever, vice versa. So it's possible that you could have misconfigured the system. So that's there as a feature. There are a bunch of Windows Client Server applications. Windows Client Server, what does that mean? That allows all of our applications that we have that are GUI based, graphical user interface based, graphical, right? All of those are available in a client server command line type of interface. Now that allows you to do automation, repetition, regression, and all of those types of things in a programmatic fashion, rather than having to manually exercise the graphical user interface. So practically every one of our GUI applications has a Windows Client Server command line type of application. So we've included all of the applications that we have basic for GUI are also included as basic for Windows Client Server. So you can, for example, conduct bit error rate testing or DTMF testing or pulse shape and jitter testing automatically, programmatically, by using those particular applications. This allows for automation. So if you were to use our hardware in an assembly line, you don't want to sit there manually testing these things. You want to just write a little script and bang bang test certain functions, like for example pulse shape and jitter, or DTMF or something like that. You can easily write a little program that tests basic functions. In fact, we actually use scripts to test our own hardware. We've written a suite of tests to test our basic hardware as it comes off the production line. So again, all of these applications amount to about $8,655. So we think that's a pretty good value. It makes our product more competitive against the competition there that might have similar features and functions. Of course, all of these other basic applications are still there. Bit error rate test, ability to do bit error rate tests on multiple channels at the same time on one single GUI application or one command line operation. Here are all the monitoring applications that are already existing that you get with our basic software.
Your VF transmit receive software This
Okay,
uses
that's here. Okay,
yeah,
this one
that
right here.
that
Okay,
uses a simple GUI to perform analog transmit receive functions such as tone, digits, file with spectral displays and speaker. So it uses a simple GUI to transform analog signals.
right.
That's
Okay,
the 605, and all these other things, I think they're all
yeah.
familiar with that.
Okay,
Yeah.
so what Shishi's saying is some of our T1E1 hardware has analog interfaces. Um, the T-Scan16 does not have analog interfaces, nor does the Octal card. It does not have any analog interfaces. But all of the rest of these, the T-Probe, the Express card, and the Universal card, which is the PCI interface, all have analog interfaces. So that means you can take a single time slot either on input or output and convert that from digital to analog. Now, if you wanted to use our hardware only for analog, then you can do that. And Shashi was just speaking of this application here, Dual VF TX-RX, which is meant if you want to exclusively do analog testing with our T1E1 hardware, you can do that with this application. It simplifies analog operations very substantially, so that you don't have to worry about time slots or any of those types of things. You just connect into our hardware at the analog interface and do all your testing at the analog level. Okay. All right. So that's just a quick summary of the new applications. Quite a lot has been added. And so now we're going to go through all of those applications in a little bit more detail. And so the first one we'll dispense with is this E1 mu law, T1A law, as I had mentioned. This is not used very much, but can be useful under certain circumstances for certain countries, and it may be in the situation where you're in between countries. So that is allows you to do this oddball type of codec. Okay, so the next important thing is this Jitter Generation and Jitter Measurement. So these two applications here. So we'll just go over that. So these are graphical applications, and I also mentioned that in Windows Client Server, you can also automate this measurement. But it's best to see this in the graphical mode. So here we see the way we generate jitter. And now, jitter, you have to understand what jitter is. It's frequency dependent, and it's also amplitude dependent. So a particular T1 pulse or E1 pulse has an ideal clock and timing associated with it. But if it deviates from that in any way, then we call that jitter. And that deviation from the ideal can be measured either in time domain or in frequency domain. Obviously, if the ideal instant when the pulse should start is different than when it actually starts, either by plus or minus some few nanoseconds or more, then we call that jitter. And the way that varies, that jitter varies as a function of frequency, meaning how jittery it is. In other words, is it changing rapidly, that ideal versus instantaneous, or is it changing very slowly? Obviously, slower is better, right? Because if jitter is high frequency, then the receiver is going to have a problem getting that bit. So just to make it somewhat simple, jitter can be measured in time domain as just the displacement between ideal versus instantaneous, or it can be measured in the frequency domain as to how it is varying over time. And so we can generate jitter both in time and frequency with this jitter generation. And there are specifications that AT&T has promulgated and ITU has promulgated that define what a piece of equipment ought to be able to tolerate. And so we can create, so for example here in this picture, you see here that this dotted line is the compliance. In other words, jitter, this is the minimum jitter as a function of frequency that the equipment should be able to tolerate. Now, as long as this line above this mask is what it actually tolerated, what the actual device tolerated, which is good. That means that the device was able to tolerate jitter as a function of frequency, which was greater than what the requirement is. And that's what you want. This is the minimum that it must tolerate, and this is what it was able to tolerate. So there's this GUI makes it very simple to just, with a push of a button, to allow the user to generate jitter across this frequency spectrum and actually measure it. So to measure jitter, we use this application, which measures it. But in one fell swoop, this application can generate and measure jitter and give you the jitter measurements. And actually it'll plot the jitter. So all you have to do is push the button, and as long as this line is above the minimum required jitter that should be tolerated, you're good to go. And now, however, we know that all equipment may not necessarily comply, or there might be some extreme circumstances. Then in that case, you want to analyze that equipment in greater detail, and you can do so by being more specific and more exact about where the jitter is applied and how it is applied. And you can also measure that jitter in a very graphical way, as well as in a detailed manner, to see if your particular system has jitter in a specific band or at a specific frequency. And this application allows you to do that. So, simple jitter measurement and compliance testing at the push of a button, or more detailed measurement. And so this would be obviously very useful for developers of T1E1 equipment, and or just to get a quick idea of what the amplitude of the jitter is. And very helpful in just deploying the equipment. As you install equipment and you connect it up, you're very interested in making sure that the two boxes are communicating across some fiber interface, a T1 interface, across the DSX patch panel, if you know what I'm talking about. So it's very important to make sure that that is working first. And to do that, these two applications are quite useful when you run into problems. And you can also use the Windows Client Server for automating these measurements on an assembly line or a production line. The T1E1 Pulse Mask, as I said earlier, for both T1 and E1, we are able to measure the pulse shape. Now, before I get into this just a little bit, let me give you some background as to how electrically T1 and E1 pulses are transmitted between two boxes. Now, you know that earlier, maybe 20 years ago, they used to use coax, or they used to use twisted pair, or they used some sort of a datacom interface to transmit electrically. These days, everybody's standardized to the RJ48. I think they call it RJ48. Some people call it that. Some people call it RJ45. But it's two pairs of lines, one for transmit, one for receive, and the pulses are transmitted electrically using a coding scheme, a baseband coding scheme called B8ZS. bipolar 8-0 substitution. Zero substitution, so that's a little complicated. But I mean, you can read up on it. But it's simply a baseband transmission scheme. It defines how a positive pulse is transmitted and how a negative pulse is transmitted. And this picture is the positive pulse. And of course the negative pulse is the inverse of this. Now, you can see here that there's a template. This is a T1. There's a template here, and there's a upper bound and a lower bound on this template. And the actual pulse has to fall narrowly within this template. And in this case, it does. And our software says isolated pulse fits. Okay, so there's a couple of exclamation points there. That means it's good. Whereas in the E1, pulse fits also. But there, E1 uses a slightly different pulse transmission technique. It's called HDB3. H as in Harry, D as in dog, B as in bipolar, 3 as means 3, the number 3. HDB3. That's the baseband scheme. Again, electrically, it's a way of sending ones and zeros. Now, why is this called B8ZS and why is this called HDB3? Well, that's a very interesting story, and I can probably tell you that one of these days. But simply speaking, when you transmit electrically signals, you have to make sure that those signals have actual transitions in them. Otherwise, if you send a 1 as a positive pulse and a 0 as no pulse, now what will happen if you were just sending lots of zeros, which can happen, right? You would just send no pulses at all. Well, how does the other side going to know whether you're sending anything at all? No pulses versus, zeros versus nothing. Well, that's why they use this technique called B8ZS, bipolar 8-0 substitution, which means that it takes a string of bits, ones and zeros, and encodes it in some sort of a unique way to create these transitions, ones and zeros. So not every zero is transmitted as a positive, as a blank, as a zero, at the zero level. Some zeros are transmitted as pulses, actually, and all ones are transmitted as pulses. Some zeros are transmitted as pulses, but in a unique coding way. It's called bipolar 8-0 substitution. And here it's called HDB3. So these are all baseband schemes that are, have been around for a very long period of time. And there's a way of conveying electrically between two boxes reliably high-speed pulses. Similar types of things are used in Ethernet and also used in other baseband transmission schemes like in fiber optics and so on. So now, it's important that when two boxes are talking to each other, that the pulses fit this pulse mask. So we're making it very easy for you. All you have to do is hit a button, plot pulse, and the received pulse that card receives is plotted and in this mask. And as long as it fits within the mask, good to go. Same thing with E1. You're good to go here. Okay, you're all well within. If it doesn't fit within this, well, there could be an issue. Okay, and you need to probably, if an occasional pulse does not fit, that's fine. If there's a consistency in pulses not fitting this pulse mask, then there's probably a problem. And you have to fix that problem before you do anything else. And then you can talk about the actual data that you're trying to transmit. But first, you got to get this baseband transmission working properly. Okay. Windows Client Server, again, you can automate everything. Windows Client Server allows you to automate and do regression with just write a simple script, and it'll get you all of this graphical data in ones and zeros. So this is, we're just showing you here how one would actually send a command and get the data and so on. So if you were writing a little C program or a Java program or something, you could very easily write with a few command lines or a few little programmatic things, write a little program to do this, which is being done manually. Okay? All right. Okay. So any questions on jitter generation measurement pulse mask display? These are very valuable tools because you always have problems initially when you're deploying equipment. Things are not working properly, and well, this will get you beyond that. Okay, no questions? Then we'll go on to the next application that we've included as part of the basic application, and this is called Stripchart. Shashi, do you want to explain this one?
Here we can see, when we capture files, we can see signaling and also the voice files at the same time. The second pane gives you the signaling level, and the first pane gives you the voice level, and you can see both east and west. This is very important when you're capturing like MFCR2 calls, so you know when the signaling happened versus when the voice actually was captured. So this, as we say here, this is you can see the PCM data and signaling at the same time, and you can gang them up and gang both east and west side and see the plotting of this signaling and the PCM.
Right. Okay. So as Shashi said, this is for channel associated signaling, right? So the old way of signaling is called channel associated signaling. That means each channel has signaling associated with it. This on-hook, off-hook stuff, or R1 or MFCR2. These are all, and MFCR2, for example, has umpteen different variations, still being used out there. This is, and in that channel associated signaling, we use tone-based addressing. So here you see, if you were to magnify this, these would be the DTMF or MF or MFCR2 digits. And it looks like here we're sending some digits in the east and the west direction. This is probably not any exact signaling, but we're sending the DTMF digits. What are DTMF digits or MF digits? These are the addressing, right? Normally, when you make a call, you have to send the digits that you're the called party and the calling party. So when you're using trunk signaling, you have to send both the originating address in DTMF mode and the terminating address in DTMF or MF mode or MFCR2, and you do that with these tones back and forth. And then after the signaling happens, then you see the voice. So normally, this application would be useful when for example, MFCR2. That I know from previous dealing with customers, MFCR2 is a bear to diagnose or initially get up and running because it's got a lot of protocol aspects to it between. On the trunk, it's a compelled form of signaling, and I don't have time to discuss what compelled means, but essentially it's a very reliable form of tone-based communication. It is a little slower, but it is it's used all over the world as we transition from analog-based signaling to digital signaling, like ISDN or SS7. So since each country has their own MFCR2 variation, I know that this application has been useful in figuring out who's got the wrong configuration and why, etc. So it's good. It gives you both the signaling in this pane, the digits, and the voice band there. We call this strip chart because it looks like a strip chart. And so we made that available. I hope you guys are happy. Let's see. Signaling bit transitions. Shashi, can you explain this one?
Yeah, you can see signaling bits changes as it's happening on different time slots, on all the time slots, and you can log them, and you can record them, and later on find out what exactly happened with the signaling. On all the cards, in case of T-Scan 16, you can monitor signaling on all the 16 cards at the same time and on all the time slots, and you can log them to your file. And if there are any problems with the signaling, you'll be easily able to figure that out with this application. So basically, it permits detailed analysis of the signaling bits.
Okay, so let me emphasize a couple of things that Shashi just mentioned. That this application can be invaluable if you are doing channel-based and channel-associated signaling. And that means on E1 you've got 30 channels of signaling going on. This is happening on 30 channels. This is happening on time slot 5 at the moment. And you can change this to go from 1 to 30, right? It's happening on 1, it's happening on 2, 3, all the way up to 30. And this application is recording all of that on all of these time slots. So on all 30 channels, it's recording the signal. And as calls go up and down, this thing is recording all of that. So if there was an issue with signaling, channel-based signaling, channel-associated signaling, so this application will record the signaling bits as they're occurring on all the 30 channels. And hopefully then you could analyze the signaling later if you recorded it and determine where the problem is.
Vijay, I know some of the customers who've been using this application like for months together to analyze their problems. I mean, they keep logging this signaling months together on many cards and many different time slots, and this is very useful for them. They don't have to be in front of the PC. I mean, whenever they'll know exactly with this timestamp, they will know exactly when it happened, and they can debug the problem.
Yes, and for example, like you have an AT&T switch or a Northern Telecom switch, and then you've got a PBX. When you have channel-associated signaling, what happens is channels can get stuck in some sort of a busy state or an awkward state, and that particular channel is then unusable for a little while. So that's why in channel-associated signaling, usually these trunks are rotated and reset every now and then. So this type of application would be very useful in determining those kinds of abnormal conditions. Okay, all right, so the next application that I had mentioned earlier is there was a host of Windows client-server applications. As I had mentioned earlier, every application that we have in the graphical user interface, the GUI, the graphical applications, are duplicated in this client-server mode, where you can programmatically get the same information, not in a graphical manner, but in a programmatic manner. So you can do regression testing and automation and so on. So every application that we have in the GUI is also duplicated here, and so this is that application. And the beauty of this application is your hardware can be in one location and your program can be somewhere else on the internet. So you can deploy the hardware at Timbuktu, and your program that is talking to that hardware can be at your location, wherever that is. And you can just tie in to that hardware through this TCP/IP cloud and run your program. So so remoting repeatability, automation. That's what this Windows Client Server allows you to do. And you don't have to be in front of the PC itself. Okay. All right. Next application. This we mentioned this very briefly, and I'll let Shashi talk about this. She's played with this quite a bit.
Yeah, this application is available only for T-Probe for now, but as we just mentioned earlier, we can bring it to other platforms if necessary. But this one uses a very simple GUI to perform analog transmit and receive, such as transmitting tone, transmitting digits, file, and for FAA we use like SS1 analysis and generation. So this uses a simple GUI to perform analog transmit and receive, and you can use this with high impedance also.
All right. So Alfredo asks, can you use probes from other vendors? I presume that what you mean, Alfredo, is that can you use a probe like our these cards or the T-Probe of a different vendor and use our Windows Client Server program to talk to it?
Exactly.
No, you can't, unfortunately, because obviously the different vendors' probes are going to have a completely different architecture to them. And now I think maybe what you're talking about is like SNMP. There is a standard like SNMP where a particular probe or hardware can relay information about its operation or its measurements in a standard way to a network monitoring system. And now usually that is very limited in what the type of information that can be conveyed from that particular probe. It's usually simple things like synchronization, framing, all those types of basic things. So in case you have lost a connection with that probe has lost a connection with its device under test, then that information can be relayed to a network monitoring system. So maybe that's what you were getting at. So you can take our probes and convey that SNMP type of information, which is very basic information, via SNMP. You can do that. So we have people here who are SNMP experts who can show you how to do that. You can use our probes to extract basic information about framing or connection or etc. In sync, out of sync, loss of carrier, loss of sync, etc. Yellow alarm and remote alarms, and convey that information via SNMP to a network monitoring system. So that you can do, but a lot of the complicated things that we're talking about here, which are very unique testing things, are specific to our hardware and our software. Does that answer your question?
Yeah, I understand. No, well, I wanted to know about the possibility of using some of the existing hardware that some customers may already have bought. But I understand the difference, and I got the answer.
Okay, very good. All right. So this dual VFTX-RX application, what makes this somewhat unique is it's got everything on one screen. It's got a little spectral display here. It has the
Speaker.
Speaker, transmit, receive digits, transmit, receive tones, file, etc. All for analog interfaces like 600 ohm and 135 ohm and so on. Okay. All right. Now let's go on to the next application, and this is the real-time multi-channel audio bridge. Now that is a mouthful. What it means is this. It's actually very simple. So we have a speaker. If you go back to our our platforms. Some of our platforms have built-in little speakers. This has a speaker, this one has a speaker, the PCI card has a speaker, the USB unit has a speaker. The Octo card and the TSCAN 16 do not have speakers. The little miniature speaker obviously has certain audio fidelity issues. In a noisy environment, it hardly does the job. But I mean, in some ways, you can get an idea of what is happening on the particular time slot. Now, this is where this multi-channel audio bridge. So in the TSCAN and in the Octo, there are no speakers. But a particular time slot on a T1 or E1 can be listened to by a unique method. And that unique method is what I was going to talk about here. We use this real-time multi-channel audio bridge. And
yeah, this application gives us the ability to send audio between sound card and T1E1 time slots. It provides a bridge between T1E1 time slots and sound cards, and there are many codecs supported: ALA, MULA, G722, 16-bit linear, etc., and both in mono and in stereo mode.
Right. So, like, if you had the TSCAN 16, you've got 16 T1s that you're monitoring. 16 T1s times 24 time slots, you're talking about quite a number of time slots there. 16 times 24, whatever that is. That's hundreds, I think. So if you wanted to listen to one particular time slot in both directions, then you could do that by this interface. It will just pipe that particular audio, convert it from MULA or ALA or whatever codec it is, convert it to sound card compatible audio, and send it through the sound card, which is probably on a speaker, and then you can use that to crank up the volume and listen to it. So that's the beauty of this application. It allows you to listen to audio on any time slot and it has all these different codecs as well, in case a particular the T1 or E1 was using something other than ALA or MULA. Okay, so this is actually quite useful, and because higher fidelity, using the speaker, the sound system, which has greater audio range, dynamic range, you can turn up the volume and so on. And it's great for a lab environment or a real environment. All right, so we're going to go to the next application. Shashi, you can take over here.
Okay, yeah, we can transmit and capture DTMF digits using this application. MF digits, DTMF digits, MFR2 forward digits, backward digits, and specify different power levels and transmit and receive. Yeah, we can dial in DTMF, MF, MFR2, MFR2, and specify on time and off time, give the digit power, give the sequence, like when to send different signaling bits, all the transmit events, wink, and transmit digits and receive digits. We can transmit all these digits and receive digits for analysis.
So this DTMF application has a lot of features to it, and it allows you to manually control them. So here you can see that the actual DTMF parameters can be controlled. So as you know, DTMF digits are dual tones. That means that in fact DTMF stands for dual tone multi-frequency. So each digit is actually like a 1 here, for example, is 697 hertz combined with 1209 hertz. So those are two frequencies that combine together to form the digit 1. And now you can, many times you can have digit distortion. meaning that the frequency, the high group frequency, could be off, the low group frequency could be off, and so on. And this allows you to control all of that. Believe it or not, there is a specification promulgated by ITU and AT&T that actually talks about DTMF digit transmission and compliance. Now, DTMF digit transmission is used by IVR systems, banks. For example, I can probably call up my bank and get my bank balance, and I have to do that by calling that bank and then punching in a PIN code and so on. And it'll I can navigate the IVR through DTMF digits. So obviously, it's used in a variety of actual applications. All right. Again, this is available with the Windows Client Server. You can send digits using that application.
Yeah, Capture DTMF digits gives you the full details with the timestamp, frequency, on time, off time, and power, and can be logged on forever. You can save that file, as you can see in this screen.
Right. So here we're saying that an MF digit was received, a 1 was received at this particular time. The duration was 50 milliseconds. The nominal power was minus 10 dBm, and it constituted a 700 hertz at the low frequency and 901 hertz at the high frequency, minus 13 minus. So it gives you a lot of detail about the actual digit, and comes in handy if you are having problems with DTMF digit transmit. Believe me, you will always have problems with DTMF and MF and MFCR2 digit transmission in these new networks, okay, next generation networks. When you are transmitting these digits, they have to be converted to packet and back to PDM, and in the process, it's never done correctly, and you will have problems. So a lot of issues like this would have to be resolved by having an application like this. Okay? Good. Okay, so here is, we covered real-time multi-channel audio bridge. That's this one. So again, this allows you to take any time slot and feed it to the sound card system, PC sound system. Jitter measurement, pulse mask display, we talked about that. Signaling bit transitions, DTMF transmit and capture, and real-time strip chart. So we talked about all of those. And here we talked about jitter generation. We talked about the simple application for analog that allows analog interfacing and testing, very simple. We talked about T1A law, mu law, T1A law, E1 mu law, which is that strange application, and all of the Windows Client Server applications that do basically the same thing.
So basically you're saying that many important special applications are given for free.
Well, given, I wouldn't say free, but I mean, the basic hardware, the basic hardware costs some money, but we've included a lot of new software that was originally
required licensing.
Required special licensing and required additional cost, and now it's being included. But we can now go through some of the basic applications that still come with the basic software. Well, here's one application. Maybe we should talk about this one. Cross-port through and cross-port transmit. Almost all of our hardware, maybe Shashi, you can talk about this, all of our hardware now, except for that USB, except for this one platform, let's go back here, except for this platform, this USB, which is still a compact, portable unit that's still very popular, all of these other platforms, the Octal, the HD Universal, the PCI Express, and the T-Probe, they all have this cross-port transmit and cross-port through, which is a very, very useful feature. It simplifies cabling. So I want to have Shashi go through that with you.
Okay, this one avoids complex cabling, and it acts like outward loopback, and connection is not affected even if the PC loses power, and data is passed seamlessly. And it's better to use a bridge mode in this cross-port through mode. Again, the next one is if you want to transmit some error or data, if you want to delay some data, you use this cross-port transmit mode. In this mode, you can use it as a drop and insert mode. You can insert errors and data can be delayed, and typically use a terminate mode because you want to transmit all this error and data. So this is cross-port transmit mode. Again, this mode avoids complex cabling. If you want to use like USB analyzer, you have to use this complex cabling, but this mode avoids complex cabling. So this is the cross-port transmit mode.
Okay, so just to clarify or to reiterate what Shashi was saying here, cross-port through mode. Okay, so what that means is, so you've got a box A talking to box B, right? A is talking to B directly. Let's assume A is connected to B here directly. Well, all you have to do is break that connection, connect A to the T probe or whatever, our platform here, and connect B to this platform and put our box in cross-port through. So what happens is this signal from A comes down, goes across, and to B. And the B signal comes down, across, over to A. So A is still talking to B. However, now the A signal is also being received by our probe. The B signal is also being received by our probe. A is still talking to B in a non-intrusive fashion, and let's assume our probe, somebody turns off the PC connected to this probe. Well, these things are still there. It doesn't matter. So A is still talking to B. And then bring up this PC again, and again, no problems. A will still be talking to B, and again, now you can monitor it. So it's a non-disruptive, non-intrusive way of monitoring, and you can just leave it connected this way, and makes life very easy. You can just if you were doing this remotely, you just call into this T probe here, or whichever platform it is, and then start monitoring A to B communication. So it's very useful. And this cross-port transmit allows you to do drop and insert. Now, okay, so drop and insert is kind of a complicated feature. What it means is A can be talking to B in all of the time slots, 1 through 24 or 1 through 30 for E1. But you can alter one of the time slots in either direction and not affect all of the other time slots at all. So sometimes this type of testing comes in very handy, and again, this allows you to do this drop and insert. And this also comes in handy for error insertion. So you could take the A talking to B and run it through our hardware and insert errors in a very precise manner. So our error insertion software is very sophisticated and allows you, and by the way, it's part of the basic software, it allows you to insert errors in a very precise manner to test unique things. Not only can it insert errors in random, Gaussian, burst modes and all of those types of things, but it can also insert errors in very specific bits and very specific locations. And that might come in handy, and a lot of our customers do find that feature very useful when they're doing very complicated testing, or they're using T1 lines for very specific purposes. Okay, so these two are very useful features that are available with all our platforms except for that one platform, that the small USB platform. So VF options, we talked about this. Shashi, do you want to pick up here?
Sure. Here we have different VF impedances allowed, like 135, 150, 600, high impedance, microphone and headset. So we can insert VF or drop any time slots in the VF on both the ports.
So one of the things that we have on the VF is this some of the platforms allow for balanced connections, and some of them are unbalanced. So the T-probe and the express cards have balanced interfaces, and the USB has the unbalanced interface. So any type of VF connections are possible. Okay, so these are all basic applications that I think you all are familiar with. Byte values, this allows you to see all of the 30 channels or 24 channels in this unique way. Signaling bits. Okay, this is signaling bits, all 30 channels. Power, simultaneously all 30 channels. DC offset. When you are using T1 or E1 for transmitting audio information, voice information, that conversion from analog to digital has to be very clean, and it has to remove all DC, because, as you know, audio does not have any DC component to it. It's all in the frequency domain. And so this measures that your analog to digital conversion at the very source is clean. And of course you can measure frequency and power as well. And now you can look at all of the time slots and all of the frames in real time as well with this multi-frame application. Real time meaning this will be changing as the data is changing. Here's another way to take a look at that same data. If you look at the data in the T1 or E1 world, you know that T1E1 can be used for transmitting any kind of information. It can be used for transmitting voice, analog information, tones, digits, fax, modem signals. You can transmit IP traffic. You can the T1E1 lines are used in the wireless domain for used in GSM systems, in 3G systems, to transmit compressed audio information where codecs are involved. So if you look at the data in this real-time bitmap method, you can look at it graphically and immediately realize, oh wait, these time slots are changing rapidly, so it must be something like voice traffic. But this is static here, and it must be something different. It looks like it's very repetitive, so it must have flags. Maybe it's HDLC traffic. This looks like it has some sort of idle traffic here. Everything is the same. This looks like it's very time slot specific or bit configuration specific. Like it looks like bits 7 and 8 are being used for something, and so this could be like sub-channel traffic. So at a glance, you can see what's going on. It's a very useful application. Sometimes you can use T1E1 time slots to transmit ASCII information. We have an application for that. Time slot, if you want to just zoom in on a particular time slot, you can do that with this. And of course, my favorite applications are these applications that allow you to look at audio information in a graphical way. A spectral allows you to look at it in a frequency domain, and oscilloscope allows you to look at it in time domain. So very useful. It is useful for me. I can always debug problems using these applications. You can also listen to audio using that audio speaker that's on the unit itself. You can use this application. As I said, the alternative to this is that real-time multi-channel audio bridge, which I hope that everybody will use that because it's a higher fidelity and so on. Active voice level. Well, way long ago, the ITU decided, well, ITU said that, and AT&T said that voice ought to be measured in a unique way. It's a different type of signal. And there's a measurement technique for measuring voice. Idle voice, or in other words, inactive, or active voice, and so on. So this is called P56 actually. It says here ITU P56, active voice level measurement. So if you've got predominantly voice, mu-law, A-law in your T1E1 lines, this is a very useful application to look at whether the levels of the voice are properly set. Bit error rate test. If you want to talk about bit error rate test?
Yeah, bit error rate test. We support all full frame, fractional time slots, unframed. So variety of standard data patterns are available with this.
This is the way it works, and you don't really need to understand exactly how it works, but you can also do fractional bit error rate. You can do drop and insert bit error rate, very flexible bit error rate. One of the first applications that we implemented. We also have enhanced bit error rate so that you can do error, since our octal cards and our T-scan have multiple T1s on them, and you want to be able to do, at a glance, do bit error rate testing on all of the T1s or E1s at once. This will allow you to do that very easily. This is just another look at it. Transmitting tones, you can do that, transmitting tones. You can send noise. You can transmit specific types of patterns using transmit multiframe, transmit signaling bits, specific signaling bits in specific time slots. You can measure delay. If you have a digital channel and you want to measure delay between A to B very precisely and accurately within microsecond resolution, this is the application for you. And this is a diagnostic application to make sure that our hardware is working perfectly, which it usually is. Error insertion. By the way, we recently released new software. On May 5th, 2015, we released new software. It is on the web. So for customers that already have our applications, our software, they can download the latest software. So if you have a customer that already has our hardware, and as long as their warranty is up to date, they can immediately just download the latest software and have access to all that $8,000 worth of software that just has been made available with the basic software. That certainly is very attractive, I think. This error insertion application has been, a lot of features have been added to it. It's really a very powerful application. Allows you to do, I mean, I'm willing to say that it probably has more error insertion flexibility than most any other platform out there, because it has so much features, so much capability. So in a lab environment, it's very, very useful. Here's a way of achieving lots of delay. Use cascading error insertion application. Here's the actual error insertion application. It looks like it's a little complicated, but it's not. It's very easy to use, and it has a lot of features. Like, for example, look at down here, automated error rate. You can insert error rates at precise error rate. I'm talking about precise now, okay? That means the number of errors inserted will be exact, and at this exact error rate, and it will be measured exactly. So, very powerful application. And I want to thank you, and Shashi wants to thank you for your patience and listening to all of this.
Thank you, Vijay, and thank you, Shashi. Thank you, everyone, for attending this. Thank you for the presentation.
All right, thank you.
Thank you.